catch up. It's mostly about JavaScript. We're going to discuss about JavaScript and everything pertains beyond JavaScript. So today we have Jodom, who is going to be like the first person to run the series and stuff. So Jodom is currently based in Canada. Said that he said is at Microsoft. Yeah, basically he came straight from JS into software engineering and relocated from Kenya to to Canada. Then you got Mohammed. Mohammed Mwijaa is also like was also mostly doing JavaScript with JS, but again shifted to programming, mostly consulting and yeah, for US-based firms, that is. And me, the organizer, yeah, I'm just the geo geek. And then there's the geo community, which is like everyone else, yeah, because without you, uh, then this won't be possible. And yeah, so I appreciate everyone for taking the time and being here. So today it's just pretty simple, just the usual intro which I've done, and the guys will introduce themselves when talking. Then there will be presentations, which is mostly Jodom, and then Mohammed, and then we can do our discussions. I will release Jodom immediately after he presents, because yeah, it's pretty working early in in Canada, way early, and he's also about to travel. So he's also got a flight to catch. And also there is when we just do normal discussions, if anyone has any questions, yeah, we'll tackle. And then if there's any other business, and definitely we usually share the resources. Okay. There is someone on unless just kindly mute, please. If you have your microphone on, kindly mute. Hosea, you have a music on the background, kindly mute your microphone. Okay. Yeah, and so it will be like a 30 minutes, and that's it. So yeah, why we are looking into JavaScript is the most popular programming language in the world. That is right now. It's usually number one. Yeah. So and it's because of several reasons. It's also growing. Like right now, you can do some machine learning stuff with the TensorFlow JS. You can this right now about doing components when doing front end development. Front end development is basically the things you interact with, like the user interface. For example, when you are logging into Facebook and stuff, what you see. So they're like React, Angular, Vue, and then right now also JavaScript has got the backend, which is the Node.js, and with Express, you can do backend development. This now the areas that you don't see, these things that store the database. If you're changing the username, the backend component that is. Yeah. Then in GIS, you've got advantages of definitely map visualizations. Maybe you've done your analysis, you want to put on the web. You've got Mapbox, open layers. We've got even Session for 3D visualization. There's also JSTS. This is for it's derived from the Java topology services, like doing special predicates, just the special queries thing. So it has got that capability now. It's a wrap up from Java. And then, we've got open layers, leaflets, way more than here maps, Google Maps, you can name them. And also right now, Typescript, which is a superset of JavaScript, was developed. This is something Mohammed can talk about later on, or even Jodom can mention. Okay. So for a start, they usually tons of free resources even before we look into it later on. But yeah, in YouTube, like Traverse Media is like usually popular. They've got over millions of subscribers and they focus on web development. There's Academy in the second person. There's Dev Ed, Coding with Mosh, and way more. Extra rider is great, but his courses are mostly paid. It's not that free. Uh, I've mentioned here free, so this four are like free. This book is kind of popular, like most recommended, but yeah, JavaScript and jQuery. You can check it out later on. So yeah, basically that's it. But yeah, we'll discuss more. So I'll just give it back to Jodom.
Hi guys. Hi. I am Jodom. I am what? It's really great to be here. So I'm Jodom. I've been a software engineer for about 2 years right now. Slightly like straight out of college to what I've been doing. I work with a team which is doing like our main focus area is called collab. So what we build is just how people work together. So that's what I think about every day. Let me not like take too much. We can talk more about this later, but I want to just dive into cool stuff. The JavaScript world. I will share my screen. Pondi has a very good slide, and I have nothing, which is challenge Pondi. If you can see my screen, tell me.
Not yet. Without a slide is great, actually.
uh, so I do not have slides. I just have to like immerse you in this. This is my editor. I literally live here. It's Visual Studio Code. It could be anything. Sorry, I'm hearing lots of echo. Okay, thank you. Yeah. All right. Yeah. So we're going to like just like generally maybe I'll walk through the goals and the non-goals today. What we're going to do is just walk through the world of JavaScript, like what the language is. Think of it as a tour. We are not going to dive any deep into anything because it's quite a lot. We may not finish it, but the goal actually is to show you as many of the building blocks as possible. So as many bricks as possible. Think of it that way. You don't necessarily have to remember everything after this session. Just like my like what I'd like you to take away is having seen things. Having seen things, you can come back later to it and say, "Oh, I saw that, so now I may now like look deeper how to use them." Right. So that's the goal today. See as many breaks as possible. The non-goal is we'll not go into any specifics, like how do you use it to build GIS applications and stuff like that. That's something we like. I think the upcoming talks will cover very well. You don't need anything. You don't need any programming language before this. But if you've done a little bit of JavaScript or any other programming language, you're in a good position. You're actually going to ask more questions, understand a bit more. I'd like that. I'd like more questions to come from you. I've listed like 2 or 3 resources up front here, but there's lots of links within the things of like within each file. There's like wherever I thought like, oh, I could link to something here, I've linked to it. And yeah, so there's lots and lots and lots of things in the internet you can read about JavaScript. But I think this is the go-to resource. After like every other thing you find, probably refresh this thing or read something or something anyway. Yeah, so I think this is the documentation of JavaScript. That is Mozilla Developer Network. If you can go to Mozilla developernetwork.com something, and then just like /JavaScript, you'll find lots of stuff there. So that's the go-to resource. There is free code camp. Everyone who asks me how to learn JavaScript, I reference them to this, specifically to this thing here. Like if you go to free code camp, like I may open the page later, but if you go to free code camp and navigate your way around, you'll find just this general section. It's about 300 hours. Sounds like a lot, but it's worth the investment. It's maybe, let's say 2-3 days or a week if we are like just going through slowly, understanding things, trying out things. It's very interactive. That's something again I like. This is if you cover this content, you know your JavaScript. So that's kind of the promise. Okay, so that's resources, and if you're ready, and if there's no questions at this point, we can start. I'll like give 2 seconds for any questions. Anyone? I have a question of mine, by the way. Like I see like, you know, we are about 15 people. Like, has anyone never written or seen JavaScript code before? Like just a general sounding, maybe, just to read the room.
Yeah, for my test, yes.
Okay, so at least one person has never. I heard Wycliffe, you said JavaScript. You've been in R mostly. All right, so let's do that. I'll also go as basic as possible, but also there are things I may mention which may not sound like, you know, understandable from the get-go, but it's okay. You can ask me questions or you can just revisit them after. So let's do this. Let's start with the fundamental building block of any programming language. So variables. I don't know how to minimize this thing up here. Okay, I'll drag it somewhere away. All right, so let's go to variables. The left part and the right part are exactly the same thing. I was writing in these documents called Markdown. So yeah, this is easier to read. This is easier to copy because it's just code, and we can we'll go through this. If we need to like show an example, we'll go to this page here, write some little bit of code and run it down here. Cool. Okay, let's do it. Variables are like, you know, we think of them as labels, how you name something and reference it later. So there could be a bucket. Think of it like I have a bucket and I want to name my bucket something. So what would happen in JavaScript or any other programming language is I'll have a keyword. In JavaScript usually that would be a const or a let or a var. Those are like keywords. You ask me what is a keyword? Those are like just, you know, some special words. Someone decided like const and let, var are things you need when you're like, you know, naming your buckets for storing things. So if I want to create a bucket called favorite language in my computer, and I want to store the word Python in it, because my favorite language is Python, I will say const favorite language and then put this thing here and then I say Python, right? This thing here is interesting. That thing that like this, the equal sign is called an operator, and we'll go to operators next. But for now, you know, just know the left part declares your bucket keyword plus descriptive name. That's how you do it. And then you put some operator, and then you put like the value. So this is the value. That's how you make a keyword and store things. Right? Cool. Okay. This is weird. I'm usually used to feedback. Yeah. So presenting this online is weird, but let's go. Okay. So there are three. I've talked about the three. I've just mentioned them. But what is the difference between the two? So JavaScript has these three. I said two just now because this one I wanted to forget about it. I had to forget about var. So we have just const and let. Const, you use it to, you know, create variables or declare name buckets that you don't want to ever change what's inside those buckets ever again. I want to create a bucket. I want to name it favorite language. And I never want to change my favorite language again. Okay? That's a const. So if I do this line here, and then I try to do it again here, like reassign using this equal operator, that is going to really complain and everything is going to be unhappy. We can do it, right? So ways we can do that is I can come down here and say node. This is a JavaScript execution environment, but this is a bit more complex. Let me show you something you can try right now, and maybe like I'd really wish for you to try right now. So if I just exit that one, if I go to my browser, this is my browser, any browser page really, and then if you are on Windows or if you are if you right click and then you go to inspect page, that will give you this thing called a console environment. Let me put it at the bottom. Okay. So if you ever want to try out any JavaScript, you can go to any browser and go to this part here, this arrow with the blinking cursor here. And you can now just, start doing things. So I said const favorite language is equal to Python. Okay, let's see what we're doing. Is it too tiny? Is it the right size? Okay.
Yeah,
I'm going to assume it's visible. All right. So this and that are the same thing. They look alike. You can do similar things here. For quick experiment, let's do it here in my browser, because I know you have a browser and I know you can try this with me. So you can say const favorite language is Python, but then now let's change our favorite language to JavaScript and see if it works. So I say favorite language equal to something like what? JavaScript. Let's see what happens. Yeah, things start yelling at us. That's because we use this keyword here, const. This bucket, its values will never change. But if we say it, and we can clear that, we can clear with this thing here, or yeah, whatever. So if we said we declared our bucket using the let keyword, right? And so I say let me use some other name like ABC equal to some value, right? So my bucket is now called ABC. Now I can do things like ABC, right? If I say ABC, it's just telling me this is the value inside that bucket. Now I can change the value inside that bucket because it's declared with a let keyword. So I say ABC equal to some other value. Okay. Now see, it's already telling me, yeah. So the value of ABC, the latest value of ABC is some other value. We replaced that one with some other value. So those are the two you need to know. We have const, things which will never change, let, things will change. Var is the old way of doing things in JavaScript. All your buckets used to be named with var. These days we are like, more fancy. We have asset. So we split var into these two, const and let. So just forget about var. Var has its own, its own weirdness. So it's likely going to shoot you in the foot than anything. So just forget about this one. Don't use it. You may see it in code if you're reading JavaScript code today. Like, you find some page and then you see vars there. They're okay. They still work, but they're not the best. Okay, that's variables. The things to remember. I think I've mentioned this one. Const, things you can never change. Let, things you want to change later, maybe. Var, forget about it. Things you can look up is, when I say ABC here, where can I access it? Where can I use it? That's called scopes of variables. And then things like shadowing is related to that. I don't want to go into it, but if I declare, like here, if I say const favorite language is there, and then we will talk about functions, but if I had a function, let me prime you. Functions are things, you bucket some logic in something reusable. So we'll talk about them a little bit more in a short while. Okay, so if I had something else and then I go into it and then I redeclare the same thing, so I again say const favorite language is Python. Will it allow me? Will it not allow me? And what will happen? So that's variable shadowing. So these two are for you to go look up maybe. And there's a lot more, but those are the things I think are interesting about variables. Okay. Let's go to operators. We've mentioned one of them. The one we've mentioned is the equal to. We've used it, and I think it's in any other language. So there are a bunch of them. There is arithmetic, so just addition, subtraction, division. And there's this interesting one, the modulus or the remainder operator. There is the equal sign for assignment. We talked about that. There is the addition. So addition assignment, subtraction assignment. Plus plus is a shorthand, like, there's a lot of detail there. Maybe you can go to this link. This is again MDN, so Mozilla Developer Network, and you can see a lot more details about these things. My favorite is this one, the ternary, because it will, you can use it to do things like, I want to say, let me give an example of that. So we clear here, and then I want to assign the value of this thing here. Morning. So morning is my bucket. I declare it a lot, but I could have used a const. Okay. So morning, and then I say is I have. So I want to, morning can take two values, true or false. Okay. I will check some condition, and I'm writing this is not real code. I will check some condition. If this condition is valid, then I will say the value of morning is true. Otherwise, I will say the value of morning is false. So the operator I'm showing you is the question mark, the full colon, and how you use it. So you use it to assign this value to morning or assign that value to morning. That's all. Sorry about that. We can go a little bit more into it, but this one you use a lot. It's my favorite because I find myself using it a lot, and it's just neat. Okay. Things to know about operators. You should read them. The ones you'll mostly, these ones I think naturally you'll pick them from any other place. These ones, some of them are shortcuts. This one is another favorite, the 3 dots in JavaScript. If you ask me a question, we can dive deeper into this later. It's called the spread operator. There is comparison. Let me just mention you should use the 3 equal sign. In Python or in most other languages, you use 2 equal signs. So let me delete this part here. So comparison in JavaScript is 3 equal signs. There is relational, there is unary, technical term there. Unary just means this thing will work on just one thing. Let's say we declared ABC, but I can say delete ABC. So remember, the plus takes 2 values, A plus B. A plus B. This is mine it operates on A and B. Unary operates on just one. Delete A. Okay. So things to go, just go read more about operators. And I know variables and operators, if you're just new to programming, they easily may just, be very abstract. It's like when you're learning math and then you're like told plus, divide, what are those things? Anyway, we also meet them again in programming. They are not real world things. It's not very easy to relate them to, things you see every day. But yeah, those are the basic building blocks. Beyond that, you're ready to play with more, interesting things. Any questions at this point? Yeah. Hi. Okay. Let's go to types. And by the way, Pondi, please remind me of the time. I might do a hard stop at some point because JavaScript is wide, but let's cover as much.
Sure.
Okay, cool. All right, so types. We've covered variables. Those are the buckets. We've covered operators, the things you use to operate on values in those buckets, and types. Types is just, categories of the things you stored in those buckets, So I could store cows, I could store goats in those buckets, right? So there are the base definitions of things I can store in those buckets. So let me collapse this thing and so let's start from the first one, the number. Numbers, just like math numbers. So also JavaScript defines them just like any other programming language. Numbers. But JavaScript is easy in the sense that it only knows one type of number. Every number is equal to every other number, Like you go to some languages and they tell you like decimal places are different from full numbers. and maybe stuff like that. In JavaScript, everything has a decimal place. That's all you need to know. Everything is a float. Floats are numbers with decimal places, and they go like that. So this is an example of a float. Now, if I say 1 using const declaration, so const 1 equal to the value, the number 1, this is actually the value here is stored is 1.0, or it could be 1.00000. This is the same thing. That is a float. Everything is a float in JavaScript. There is an exception. I don't want to talk about it. You don't use it. You don't need it. But it's this thing, overflows. Okay. So how you declare a number is just like a primitive like that. Const 1 equal to just put your number there. That's it. Or you have this thing here. It's called an object construction. So this is an example of a constructor, an object, a number object constructor. I know we've not talked about objects. We're going to talk about them shortly. But okay, so two ways to declare a number. Just put it there. That's a primitive, or use this thing here. When you're using this thing here, notice you can. This is an example of a string. We are talking about string shortly. And so, okay, let's go on, and then I'll come back to why there's a quote there and what will happen in this case. Okay, so after numbers, we have things which are either true or false, the Booleans. Okay, so Booleans is, we have this thing called truth or truth or false. Okay, so we have things which are false, which means they have, in computer, they have the value 0, and things which are true, which have the value 1. We are talking binary. Okay, so things which are false are this thing here, the word false, an empty string, so that's quote unquote or double quote. The number 0, the number -0, that is an interesting one. I'd be interested to know if someone knows about this. Yeah, but it's related to the thing we talked about here, overflows, like representing big numbers, and all numbers being floats. I suspect I've lost some few people, so let me not lose you any further. Okay, so things are either true or false. Those are Booleans. How to create a Boolean is you just again do like a number. So name your Boolean bucket and then give it a value, true, or do a chain of operations which resolves to true or false. In this case, I'm actually operating true. This is again another operator. We talked about operators here. Okay, this is the OR operator. Just to switch it up, this is the AND operator in JavaScript. So it will look at this side and look at that other side. We could go indefinitely and do a bunch of things there. So this is just a chain of Boolean operations, things like that. Cool. Those are two ways you create a Boolean. Mostly you never do this. What you do is, you are executing things which will result in true or false. So that's an application of Booleans. We'll see about them shortly when we look at conditions, the next page. Okay. Remember, I mentioned this. When we are comparing things, we use the 3 equals. You can use the 2 equals. That's not advisable. So just use the 3 equals when you're comparing things. A equal B. So this will result in true or false Boolean. That's all there is to Booleans. Any questions at that point? Am I too high level? Am I going a little bit too deep into this stuff?
That's good. I'm not sure,
Okay.
but yeah, but
You're just fine.
yeah, okay.
Bondi, you should not answer this thing.
Okay.
All right. Okay. So we've covered, in terms of types, we've covered numbers, we've covered Booleans. Those are 2 basic bricks. Think of, let's go back to the brick analogy. Things you just should see and know they exist. One more of those is strings. You know about them, like our names are usually strings. Any word, a sequence of characters. So the alphabet and everything. So whatever. They're usually under single quote or double quote. Those are both allowed in JavaScript. That's how you create a string. Again, the assignment. So that's a string, that's a string. There is also, again, a constructor. So just to recap, there are two ways. We have the primitive construction of something. This is also a primitive construction of a variable. Then we also have these object constructions of a variable in JavaScript. If you go a little bit, there's a third one, which will add this keyword. We talked about keywords, so like these special words. So new. That one there. That does something interesting, but you never really need it. So two ways: create a primitive const abc equal to whatever value, or const abc is equal to some constructor and whatever you want. Strings. In things to remember, I say things like if you want to, you created something or you're suspecting something is a string, you want to check that it's a string, you do this thing here. You use type of operator on the thing you're suspecting is a string, and then you do like triple equal, like this is the type of string. This is something you can look up later, but it's it's called assertion. So we are just validating that the type of this X here is a string. That's something you should remember. Okay. Again, I've also mentioned the new compared to just without the new, and compared to primitive. Cool. You should go look up how the things you can do on strings. So you can check length. You can add two strings together. What does adding two strings? What does adding two strings mean? You can change the casing, capital case, lowercase, Pascal case, whatever those things are. You can get a portion of a string. So if this whole line, that whole line is a string, and then I'm writing code and I just want from here to here, how do I do that? That's something you need in any language really. You are writing things. There's this interesting topic called regular expressions, and I leave that to you. Let's not open that link. It's a can of worms, but it's also a lot of fun. Okay, that is strings. Should we go to objects next?
Yeah.
Yes.
Yeah.
Okay, so objects. Strings, we've covered numbers, strings, and booleans. Now, objects are the most interesting type in JavaScript in that, like they are very useful. It's like it's written in this one. Bracket, I just start with that. Calibres, and then I have things in this. I think if you're writing Geo applications, you mostly see GeoJSONs and JSONs, and let me not go those because maybe you've not seen them, but they look like this thing. So this is an object. Let's say let ABC, that's on everything, equal to that. In this case, ABC is an object. So this is what an object looks like when it's when it's the way it's stored. It has a property. So it has this opening brace, closing brace. It has a property, first property, second property, and each property has a value. The property name and the value are separated by a full colon. Now, the whole thing is a variable, an object variable, but if you forget about the whole object bucket, you look at just that, you notice it's also a variable. Like, it could be anything. It could be an integer, it could be a string, it could be another object. That's the beauty of objects. It could store anything in its property. Yeah. So, again, this is a primitive declaration of an object. This is a constructor declaration of an object. In this case, we're actually creating a Boolean. In this case, we are creating a string object. And then using the new again. I should not even be mentioning this because let it surprise you. Made it. So, all right. So those are objects. Objects are the best. Like objects are fundamental to everything else. In fact, almost everything in JavaScript is an object. I will mention some special objects you should go look up. Arrays. Arrays are objects which look like this. Let R equal to, it starts with a bracket. 1, 2, 3, A, B, C, 2, 3, 4, 5. So something like that. That's an array. Okay. I'm sure this should be a string, so quotes. Yeah, so this is the structure of an array, but you should know underneath it, it's just, it looks like this. It looks like this thing under the hood. So it's just a special object. Let's not go into that. So we have arrays, we have maps, we have whatever this is, weak maps, sets, weak sets. Those are special objects. If you understand the object, then you can easily understand the rest of those. Now you don't have to understand objects to understand arrays because they really hide that they're objects. So you can just, if you need arrays, you can just go read about arrays without really necessarily reading about objects. Now, the things you can do on objects, like you can check. We mentioned their properties and values. There are properties which are keys, and then their values. So key value pair. So if you say object, if you have your object like ABC here, and then you say ABC dot keys, that should give you something. Yeah. In this case, I think I changed it a little bit. All right. So we have methods which are built on objects. You should go look those up. ABC, like object.keys, object.values, object.entries, and other lots and lots of other interesting things you can do with objects. You should go look up how to delete a property of an object. For example, in this case, I like it. This one, if you want to delete first property here, or if you want to replace it, you should look that up. You should look up the dot versus the bracket notation for getting and setting values on object properties. I think I have that example here. So let's say we created first object, and then we want to access value. Okay, so we have some object, and then we want to read its second property. We can use dot second property, or we can use bracket and then the property as a string. These two are equal. These two here. Now, if we want to set, we just shift this thing, like I shifted it to there, and then equal operator, and then I put some new values. So those are the two ways of assigning, like getting and retrieving values from an object property. I think that's all we can say for now about objects. Remember, we're just going through them to see what is there, what is possible, mentioning them on the surface. If you have questions, please ask them. So we've covered, if I collapse things, we've covered all these things. We've covered strings, we've covered booleans, we've covered numbers, boolean, strings, object. Let's go to undefined. Undefined, and I also just to mention the next one now. These are two special types in that they represent nothing, right? There's this interesting philosophy of how do you show that something does not exist? You could draw something, you could draw Pondi and then say Pondi does not exist. Or you could just say Pondi does not exist, but you have to prove that Pondi does not exist. Forget about my rambling. There's that whole interesting thing called, evidence of absence. You should, this is an interesting thing. Like maybe go read about this later. And I'll share these weird notes. I'll share these notes. They are somewhere on GitHub. I'll share them. This goes into philosophy, but undefined nulls are where you represent things that does not exist. You are, in this example, undefined. Everything is undefined by default. null, you are explicitly saying this thing is empty. You are explicitly saying your variable does not contain any value. That's how you use null, explicitly saying your variable, your bucket is empty. There is one more type, symbols, and let's not go into it now. It's a new one. It's not, you'll not find it in all JavaScript. It's in JavaScript, which is like JavaScript from 2016. That's when you'll meet these symbols. You rarely use them. You rarely use them, but there are ways in which you can create things which are truly unique in JavaScript. If I create one symbol, it will be very different from the next symbol. It will never be the same. So like true uniqueness. That's how it's now supported in JavaScript. We've gone quickly through a lot of stuff, a lot of concepts, high level. Most of them may not stick, but remember, just remember the things which exist: numbers, boolean, strings, object, undefined, and the null. Where these last two, we use them for showing, like proving things does not exist. Proving emptiness. That is types. Should we take a breather at that point? Questions? Bondi, now you can ask a question.
No questions on my end. Since there are no questions from the rest.
Okay. Let's go to the fourth topic of the day, like control structures. So when you're writing programs, you want things to, you expect one thing to happen, then another thing to happen, then something else, or, if not this path, let's take another path. So control structures in any language is, how you choose the path to be followed by code. I have to mention at this point, this is a classical way of building programs. If you look at the thing called quote-unquote AI, it doesn't go through, normal control structure, the thing we are about to define now. But control structures is how I choose a path for programs to follow. Okay. The basic control structure is called the block in JavaScript. So anything under curly braces. So these things, from that to that. Example, I'll just go here. That is a block. So a block is anything within matching curly braces. So these things are considered, one logical bucket. They're not necessarily thing one, thing two, thing n are not necessarily related, but when they're executed, all of them are executed together, starting from the one on the top going down like that. At any point, I could decide to, instead of doing thing 2, let me do thing X. And that's now we get into branching. Maybe I want to do this. I want to start from the top 1, 2, 3, then jump again to the top 1, 2, 3. That's a loop. Okay, so we have a blocks: opening brace, curly brace. That's the basic control structure, the least issue. Now, I want to switch. The words I'm using are even confusing because there's something called a switch. But I have a block. I want to do 1, 2. At some point, I want to change direction. Changing directions, we use the if. So I want to do 1, I want to do 2, and have this thing here called if. I check some condition. If that condition is true, I want to do something, right? So if you use them for changing direction, if chaining, I can put multiple ifs within a block. So if this condition passes, then I want to execute this block. If another condition, I want to execute another block. Maybe I don't want to write them in that way. Maybe I want to change them in this, like very nice, so they all look related. That one, the first if here, does not look very related to the second if here, right? So maybe I want them related. So I want to say if condition 1, else if condition 2. So literally, I will go through this. Here, I will go through this, and I'll try to also go through that. Here, I will go through this, jump out, don't do the next business here. Just jump out and go do something else. Right? So that's if, else, stuff like that. Conditions, the thing I've abstracted here as condition 1, condition 2, they take this form. Left part equal, this operator again, equal, right part. The whole of it should evaluate to true or false. Cool. I talked about chaining. If, or if, else, else. If it gets too long, too unwieldy, we may want to use this control structure called switch. So these things actually, I wish we had time and then we go and write several examples. So you see them in action. But switch is like an if, where this would be like if A, then do this part. Switch is just a fancy version of if. So in fact, you may never need to know about switch. Just know about ifs, and then you say like, oh, this ifs, writing these ifs are too painful. Is there a better way of doing it? Then you go look at switch. That's it. I've mentioned here about these things evaluating to truthy or falsy, the booleans. Remember them from types. Cool. That's it. Let's look at loops and iterations. So doing something several times. If I go back to my block, I want to do 1, 2, 3, go back up. 1, 2, 3, go back up. Do that as many times as I want. That's a loop. And the way we do loops is we have for. So for starting, I will stop at 5, and I will do it after every number. So I'll do it for 0, I'll do it for 1, I'll do it for 2. That's what this plus here does. So the step is 1. This step could be 2, could be whatever. So I could start from 0, go to 1,000,000. I could start from 1,000,000, go to 0, decrementing versus incrementing. Just to mention those two words there. So loops, this is the thing I'll be doing for every turn. Loops are like turns, like I will be repeating the same thing, repeating. So this is example here. I just want to do this thing. Again, by there I should mention console.log is how you print things in JavaScript. So if you've written Python, it will just be like a print I. So here console.log I. Cool. We have for loops, simple for loops. This is all you need to know. But if you want to get fancy, you can look at for off, those are new, and for in. I mentioned let here because the value of I will be changing for like with every turn. So that's why we say I equal let I. Otherwise, we could not say const I. There are other ways of declaring this where you want to declare it's called the iterator. You want to declare the number or whatever is keeping track of turns. You want to declare it first, and then you declare your loop control. So we talked about for's. While looks like this, that's just another way of going through some things many times. Those are loops. We talked about ifs. We talked about loops. Let's go to a very important one: exception handling, exceptional events. So things usually, we expect things to go well when we program things. Things are nice, the world is in a great place, but then something happens, and then our program cannot go on. It's throwing up its hands like, no, let's give up at this point. The way that happens in JavaScript is this throw thing, right? So if we say throw failed, okay, let's go back to, I'm on the right, let's go back to our lab kind of thing. And then I say throw some bad thing. Okay. This thing is yelling at me and it's saying and caught some bad thing. Just because this thing yelling at me is a safety. Think of it as a safety. Otherwise, by saying throw here, I could have crashed the whole browser, I could have crashed the entire internet, or whatever. I could have crashed our entire application. So throw here is very powerful. It's how you give up when you're like, executing your block and going through your logic. It will happen by default implicitly in some scenarios. If we're doing bad things as a programmer, we can do it ourselves also whenever we want. So the goal with exceptional events are, things which are not accepted, like expected, like we are going through steps, but then something bad happens. We blow a tire, and now we have to go out of the road because we can't drive anymore. Okay, so those are exceptions. You can throw anything in JavaScript. You can even throw true, which is really weird. Let's do that. Throw. If we say throw true, what will it say? Uncut true. If you're reading this thing, it's like, what the hell is that? You can throw anything. Don't throw things like these things. It's recommended to throw a proper error. So now we can talk about error objects. I think for each language, there are interesting ways of creating these special things called errors, so that any other person looking at the value of the failure, they can tell exactly, oh, that's an error. So if I say throw new error, let me create some error. And then it's going to now. So uncut error, and then it's going to do that, and then it's going to tell me add XXX. This is called a stack. So when I say new error, it will also tell us exactly where our code fails and stuff. So you should look at errors, how to create errors, and expected non-errors in JavaScript. Let me say that's all we can mention about that at this point. What is the time?
Yeah, 5 minutes more for anything if you want to speed up some stuff.
Cool. Yeah. All right. So we've covered these are the base building blocks of JavaScript. We've covered variables, operators, types, and controls. How you remain in charge of your code. Like just to mention, to complete this block, just to mention, try catch. Try you should wrap everything in try. Whatever you want to do, let's say run my application, put that inside try. Like you should literally you put your entire application inside a try. Catch, in case everything fails on my application, what do I do? That's how you should think about it. I recommend you look at nesting control flows. You can have ifs inside ifs, whiles inside whiles, ifs inside whiles, try with ifs inside that. Now, after we have the building blocks, then this is now we start with nesting. How a whole program is just the bare basics put in interesting places, like the building bricks inside bricks inside bricks, and inception. So look at that. Look at inspecting errors with catch. Look at the finally keyword and how to use it. Look at promise rejections, they're equivalent to throw errors and stuff, but for promises. Yeah, that is maybe high level overview of controls. Things we are not going to cover because maybe we have to end in 5 minutes. Functions. Things are getting, so we've been searching for very abstract things, things which are not operators, variables, what are those? Then we go to functions. Functions are I have some logic, I want to define it, I want to reuse it in future. Those are functions. Let me just mention that. This page will just walk you through example of functions, patterns of writing functions, like the fat arrow, and arguments, passing arguments. What is an argument? It's just an input to a function. We can talk about asynchronous programming. Sometimes you want to I want to say go to the moon, and then I want to go also make my tea. But I don't want to watch my rocket going to the moon. Okay, so that's a synchronous. I want to fire my rocket, forget about it. It will reach the moon. When it reaches the moon, it tells me, oh, I've landed. So stuff like that. That's a synchronous programming. Fire something, forget about it. It will come back later. Promises and async await are how you do asynchronous programming, like things you fire and forget. It's a very interesting programming concept because you don't have the time to always wait for things to complete before you move on to the next thing. Yep. Things to look up. I've mentioned asynchronous programming, very interesting. How things execute, things like generators. Again, this is something like I have an operation which produces very many results, but I just want to pick one result at a time on demand. Those are generators. How you wrap functions inside functions and make functions call other functions. Functions could execute themselves, could call themselves or trigger themselves, and functions, this is functions calling themselves recursions. So lots of things, interesting things to look at, but the bare concept of a function is covered here. One more thing, or lots of other things. Again, I didn't even get time to write stuff about this. Classes. JavaScript, there's the whole concept of functional programming versus object-oriented programming. JavaScript is both. It's like a jack of all trades, Swiss Army knife. Classes are quite neat with modern JavaScript. You should go look that up. There's a link to what are classes and how you create an object. There is typing. What is I know we talked about types. When we are looking at typing, this is a different concept. When I say something is a Boolean, how do I actually know it's a Boolean or tell everyone it's a Boolean? That's typing. We have dynamic typing, static typing, JavaScript is dynamic typing. Let's not go into those. The upcoming talk is very interesting. I expect it to go a little bit into this and why we need something like Typescript or a typed language. It's a strong typed, but it's loose typed. Things like that. Structured data. I know when we want to specialize now, after we've learned the bare minimum of the language, now we want to go to how do we use the language in something building special applications. Then we started structured data. We talked about JSONs, we talked about GJSONs, which is a higher level type of JSONs. Again, these things, JSON is actually JavaScript object notation. I just mentioned here, it has nothing to do with JavaScript. It looks like JavaScript, but nothing to do with JavaScript. Cool. So linkers, higher order things. We have modules, which is package bits of code you can use maybe from other people. Maybe you're packaging your own things. And then specifically web development. The thing we've looked about today, or the focus of this talk was, purely JavaScript, the language. Nothing about browsers, nothing about, as much as we were, playing around in browsers, we could have as well have played around here in console, Node console. We could have been writing JavaScript and running it on the server. It doesn't matter, JavaScript runs everywhere. But if you want to look at web development, because you want to tie your JavaScript to your HTML, to your CSS, and to your web page, or to your mobile application, this is a good path. And then this is only just taking the concepts we've discussed today and applying them to spatial software and building spatial software. So, I know, lots of stuff, high level, we didn't dive into anything. It's cool stuff. If any of these topics are interesting, please let's have another session or just ask questions. Unfortunately, we don't have the time for that now, but yes, that's it for me.
Yeah, sure, amazing. Yeah, thanks. Yeah, we can always have a session because right now we are mostly covering intros, and definitely we'll always dive deeper after the intros. Amazing.
Cool.
Yeah.
All right. So I will stop sharing and at this point say thank you all. It's a pleasure. Pandit?
Yeah, thanks.
Take it away.
Yeah, thanks for creating the time and being available. Yeah, okay, so guys, you can have a 3 minutes break. You can do whatever you want to do within the 3 minutes. Then when we come Mohammed can pick it up. Mohammed, you're here, right? Oh, yes.
Yes, I'm here. Oh, you have unmuted me. Last time I checked, I was on mute.
Oh, yeah. Perfect. Yeah, so let's give the guys some few minutes break. Let me see. Okay, we can do from, yeah, 3 minutes from now. So that's like 14:12 on my end. To you guys, I think it's 14 something else. Oh, no, it's okay. Yeah, you're 2 hours ahead. Both guys are in Kenya, so it's the time difference. Okay. Yeah, guys, let's have a break a little bit. Then. Okay, so I think our 3 minutes break is over. If you want to grab some water, probably you've done so. Okay, looking at the charts first. Peter, yes, it depends what you want to do. If you want to do client-facing stuff, like basically what you see the user sees, definitely you'll learn HTML and CSS before JavaScript. If it's for backend, like you just want to write codes for database or some JS algorithms for the backend, then you don't need to learn HTML and CSS. But most JS guys usually like to visualize their outputs. So I think in the end, JavaScript is great because yeah, with the backend you can transfer and still use JavaScript on the front end and back end, and yeah, and you can just it's easy to and just some basic HTML and CSS is enough. You don't need to be super great into it. Okay, Moa, are you back?
Yes,
Ah,
I am back.
okay.
I was clearing my throat. Make sure
Okay.
that my voice is.
Sure. Oh yeah, so
Yeah.
it's back to you. You can enable sharing if you want to share the screen or something. It's okay.
Yeah. So I don't know where to start. Maybe introductions.
Yeah.
So I am Mohammed Mwijaa. I think some of the participants all know me, maybe some don't. I am a software engineer, full stack. I started out doing GIS, and well, I haven't really fully switched, but 90% of the work that I do right now is purely software engineering and not inclined towards GIS. So for my stack, I basically use Python and TypeScript. Those are like the base languages that I use. I'm also a big fan of Golang. I'm not yet into the advanced stuff with Golang, but I can write a few APIs and scripts and programs with Golang, and I'm really liking it. So yeah, I think today I will just talk about uh, Angular, the Angular web framework, and a little bit of TypeScript. So without further ado, I think we should just jump right into it. So quickly, so this is a presentation on Angular. Along the way, we shall also look at a few things about TypeScript, because the current version of, or rather the version of Angular that we'll be talking about is written in TypeScript. So it's important to know a little bit about TypeScript. So Angular is a web framework, a web application framework written in TypeScript. There are like, let me say, categories of Angular, and there are two of them. We have Angular 1, which is written in JavaScript. And then we have Angular 2 and above, which is written in TypeScript. The reason why it's Angular 2 and above is because the first version of the TypeScript written Angular was version 2. Right now we've gone up to version 11, which was released like 2 weeks ago. So yeah, for the Angular that was written in TypeScript, we are up to version 11 right now. For the Angular that was written in JavaScript, I think we're around version 1.2, I believe. Yeah, so that will basically not go to version 2. It will be just version 1, but they will increase the minor version numbers semantically with the bug fixes and the updates that come through. So yeah, the Angular version that we'll be concentrating in this talk is Angular 2 and above. So this is the Angular version, which was rewritten with TypeScript. So it's quite different from Angular 1 point. It has a lot of new features, a lot of, because it's using TypeScript, there's a lot of new features, a lot of tools that have been incorporated into the framework that make web development quite a breeze. So basically, a web framework is just a software framework designed to support the development of web applications, including services, resources, and APIs. In this case, Angular is a front-end web framework, because if we are talking about web services, we're talking about web resources such as JavaScript files. If we're talking about web APIs, this is generally for web development, because web services and APIs are basically a feature of backend applications, where you'll have a database and then expose services for data and other functionality as far as the backend is concerned. So in this light, Angular is a front-end web framework. It provides a standard way to build and deploy web applications onto the internet. So basically, web frameworks are there to like remove the boredom of doing things over and over again, because there are standard things that you will be doing when you're building web frameworks. So the common activities that you will be doing, that is what web frameworks have come in to abstract away, so that you don't have to repeat those tasks every time you're doing like a new web project. So although we often target the development of dynamic websites, we also are available to do static websites. And most of the websites that are done these days, or web applications that are done these days, are static websites. So if you look at the evolution of web applications from when the web was invented, people basically started writing static web applications where you just create a bunch of files, you put them online, and then when people use a URL to access your web application, they're just downloading those static assets and visualizing them in a browser. They are just rendered by the browser, and people can see what information you're trying to put across. And then came the era of dynamic websites. These are basically websites that are powered by a backend application. The backend application injects some data and functionality into that application and generates the templates for you on the fly. So there was quite a long spell that was characterized by dynamic websites, and so many technologies came across to deal with that kind of concept. Java, Ruby on Rails, Python and Django, so many tools came out to enable us to build dynamic websites. But currently, if you look at the trends, we are going back to building static websites. So using tools such as Angular, React, Vue.js, what you do is you build static assets for your web application, you host those static assets, and then for the data part, you build a separate project, which is basically an API, which exposes the functionality of the backend application to the front end using standard access, something like an API, a web service, if it's a JSON API, if it's a SOAP API, things like that. So basically, that's how the trend has been, and we are currently back to doing static websites. So server-side versus client-side, I think I've already touched on this. Server-side development is all about logic and data. Client-side is more of a representation of that data that has been fetched from the backend or from the server side. And basically, whenever you're doing an application, a web application, chances are you'll be doing a mix of the two. You'll have a server-side application, and then you'll do a front-end application, which is the client-side application that will be talking to that or communicating to that backend application via web services to portray whatever information you want to portray. So Angular as a web framework, it's just around to decouple. So Angular as a web framework, it's just there, or it was built to do a separation of concerns. You're decoupling the way you present your data and the application logic. So basically, yes, you can have an Angular application embedded into a backend application, but it's not always the most efficient way of doing it. Rather, you want to build a front-end application and let it communicate with the backend via lightweight services such as JSON APIs or remote procedure calls or SOAP APIs, whatever you want to do. But in between, the medium of communication between your front-end application and your backend is usually an API or a communication service that you connect or you use to connect the backend and so basically you'll create your front end to your backend. So Angular is there to help us with the front end part. So Angular is hello guys, can you hear me?
Yes, you can.
Yes.
Yeah, I'm thinking my internet is unstable, so I thought maybe I dropped. Okay, so Angular is there to provide structure for the journey of building an application, from designing the UI through writing business logic to testing. So basically, as a framework, it's there to automate or to help us with those tasks, designing the UI, writing the logic for that UI, testing the UI, and because Angular is a batteries included, what we call a batteries included framework, it has all of this functionality bundled into one framework. As a side note, if you look at something like React, React is not really a framework, it's a library. So it doesn't have all of these things bundled in together. The only thing that React is good at doing is creating user interfaces. So you'll find that when you want to do something else with React, you'll have to bring in a few more libraries to help React in doing that. But if you look at Angular, it's full featured. So it has this testing frameworks bundled in there. It has functionality for writing UI components bundled in there. So it's a full featured web framework. So let's look at some quick facts about Angular. It's supported by Google. Well, I think we can trust Google not to give us bad software. It's a web framework. The latest version was released like a couple of weeks ago, and it's in long-term support to May 2022. It's an MIT license, so basically it's open source. You can use the code the way you want. It's written in Typescript, and we have a few ways of where you can look at pertinent issues and news and everything as far as Angular is concerned, documentation, and you can look at the source code, everything in those two links. So what are the key features in Angular? So basically, if you look at the design implementation for Angular, you have the logic written in TypeScript, and then you have the presentation components written in HTML. So what Angular does is it takes HTML and gives it programming language features. As we know, HTML is a markup language. It's only good at presenting stuff. It's not good at doing logic and doing conditionals and those kind of things. So basically what Angular does is it gives you the opportunity to incorporate some of the features of a programming language into HTML. So that is where things like directives come in, because now you can write custom HTML tags which do custom functionality as you have explicitly defined in your TypeScript code. Also, Angular is component based, so basically you can write small building blocks the application instead of just writing one giant application. So you bring in smaller chunks to create that larger application, and in that way you can reuse parts of that code. It's easily readable because you can look at the component structure and the component hierarchy and see what builds on what. And then it also makes it very maintainable, because if you have to change something, you don't change the entire application, but you just change a small part of that application, making the entire development process very smooth. Angular supports asynchronous programming, and it does it by incorporating RxJS. I don't know if we are familiar with reactive extensions. It's just a way of using continuous data streams in programming languages. It's a very popular programming paradigm, reactive extensions. So the JavaScript implementation of reactive extensions is called reactive extensions JavaScript. So RxJS is heavily used in Angular, and if you have to be good in Angular, you have to look at RxJS and know a little bit of background and fundamentals on RxJS. I believe other languages also implement reactive extensions. For example, I know Brian, being a Java person, can confirm that there is RX Java, which is used to implement reactive extensions in Java. So basically, for you to be conversant with Angular, you have to look at RxJS. Not deeply, but you need to have a little bit of background and fundamentals as far as RxJS is concerned. Angular is cross-platform. You can use it to build a lot of things. You can use it to build web applications. You can progressive web applications. Use Angular to build mobile applications with native script or the more popular Ionic framework. So it doesn't really restrict you as far as what you can build is concerned. Angular is very performant. By today's standards, it's very performant. If you were to build a web application with Angular and use the common tools to try and figure out the performance of that web application, you'll find that it's at par with the set standards. And it does that by incorporating some fundamentals, things like dependency injection, data binding. These are all concepts that are incorporated in the framework to make sure that it's at par with the set standards as far as performance in today's terms is concerned. Angular is very extensible. Actually, I think this is one of the key selling points for Angular as a web framework. Because it's been here for a while, it has a vibrant community. It means that people have built libraries to provide new functionality into the Angular ecosystem. So whenever you're trying to do something, whenever you're trying to import functionality into Angular, you'll find that somebody already implemented something like that. So you have libraries like Angular Material, which is very popular for bringing in material design concepts into Angular applications. And you have so many other UI components that UI component libraries that have extensions for Angular so that they make it easy for you to use them in an Angular ecosystem. So you have Django Angular, which for those of us who are familiar with creating REST APIs with Python and Django, it gives you a very easy way of implementing the communication between the front-end application, which is written in Angular, and the back-end application, which is written in Django. Google promised to support Angular for quite some time because the Angular team is actually in Google. So I'm sure we can be very comfortable in saying that if you're using Angular, you are pretty sure that you'll be getting security support and performance support for quite some time. And yes, we keep mentioning this. Angular is written in TypeScript, but what does this really mean? TypeScript is not really. People want to say that TypeScript is a programming language, but the way I see it is, okay, it is a programming language, but it's a derivative of JavaScript, because basically what TypeScript does is it takes JavaScript and adds some functionality on top of it. So it's an open source language which was developed and is being maintained by Microsoft. Believe me, TypeScript is really interesting, because if you look at the trends for these the top tech companies, they always want to reuse their own technologies. So if they invent a programming language, they will always want to use a lot of it. But if you look at Angular, it's written by a team which is part of Google, and they actually went for a language that is being developed by Microsoft to rewrite their in-house web framework. That actually tells you a lot about that language, because if you look at these large tech companies, they always want to bring in their own in-house tools to build their frameworks. But the guys at Google actually opted to use a language created by Microsoft to rewrite their own in-house framework. So that tells you a lot about TypeScript, about the usability and all the goodies that it brings to the table as far as development is concerned. So basically, TypeScript is a superset of JavaScript. So it only adds syntax onto JavaScript. So basically, if you take your JavaScript code today and put it in a TypeScript file, it is still valid TypeScript. The only thing that TypeScript adds onto JavaScript is what we call syntactic sugar. It brings in a type system, which is very useful at making JavaScript to be a proper enterprise level language. So TypeScript is designed for development of large applications, and it transpiles down to JavaScript. It brings in a type system, which is basically an add-on to make JavaScript scale well. Because if you're doing large applications and you don't have type safety, chances are you'll have a lot of errors and you'll have a lot of tight coupling between components, and you end up having a terrible application. But with TypeScript, with the type annotations, with the type system that it brings in, it makes JavaScript a language that is now has the potential to create enterprise level applications. So TypeScript can be used for both front-end applications, like using it with Angular, and it can be used for back-end applications in the Node.js environment. Recently, Deno has been revealed, which is also a back-end runtime, but it has first-class support for TypeScript, unlike Node.js, which you have to bring in type definitions if you're to use TypeScript in a Node.js application. So what are the language features that we get with TypeScript? Basically, TypeScript is a type system and nothing else. It does not add performance to JavaScript, because at the end of the day, your TypeScript code will be transpiled down to JavaScript. So basically, it's not about performance, it's about type safety. I think this is one of the things that people usually don't understand. They feel like if they use TypeScript, maybe their app is going to be much more performant. No, the performance will still remain the same. It's only that now your application will be much more robust, it will be much more scalable, because you have type safety included into your application. So what are the features that TypeScript brings in? We have type annotations, type inference, interfaces, enums, generic types, all the goodies that come in with the language. Then we have some of the features that have been adopted from JavaScript itself. So classes, modules, arrow syntax, default parameters, these are all features that are available in raw JavaScript. But because TypeScript is just an add-on onto JavaScript, so whatever is available in JavaScript is also available in TypeScript. So a quick comparison on how you will do a variable assignment in JavaScript versus how you will do it in TypeScript. Basically, what you do is you define a type for what you are trying to initialize. In the first presentation, Jodom talked about types in JavaScript. So you have strings, you have Booleans, you have numbers. Those are basically the primitive types that come in with the programming language. So because they are part of JavaScript, they are also part of TypeScript, and we can use them to tell TypeScript what type of a variable we are trying to initialize or we are assigning. So in this example, first name, we are declaring explicitly that we want first name to be a string. So if you were to try and change first name by assigning a number, TypeScript will complain and tell you that you cannot assign a number onto a variable that is supposed to be a string. So if you look at the other side, after you've transpiled this code, the JavaScript version is just basically the same, minus the type annotations. So basically, TypeScript adds a type system onto JavaScript. At the end of the day, it's just JavaScript, but with some added functionality. So when you transpile it, you just get raw JavaScript, without the type system. Let's look at another example. I hope this is large enough. In this case, we are doing a class. So we have a class that is written in TypeScript, and we have the same class after the code has been transpiled in JavaScript. So basically, if you look at the code, it's quite similar, except for a few things where we have a few class modifiers on the TypeScript side. The constructor is a little bit different. There are 3 lines of code in the TypeScript class that we don't have in the JavaScript version. But if you look at the code, it's basically the same. So at the end of the day, it's still JavaScript plus a type system, and that's what TypeScript. One other thing that is different with TypeScript. If you look at this example where we have the class of person, this is a class, but it also stands as a type. So we can have an object and type it as a person and say that this is of type person. Whereas in JavaScript, you don't have these types, you only have the primitive types. In TypeScript, you can define types on your own. So basically you have your custom types that you define and then use them in your code. I don't think we'll do this demonstration right now. I think we'll just leave it for everyone to just go and do the demonstration by themselves. But if you go to that URL, typescriptlang.org, it's basically a small playground where you can write TypeScript code and see the JavaScript equivalent of that code. So Angular with TypeScript. So having talked about TypeScript, what are the few benefits that you get writing Angular with TypeScript? Mind you, Angular was written in TypeScript, but you can still use other languages to write Angular applications. For example, you can use Dart to write Angular. You can still use raw JavaScript, plain JavaScript, to write Angular applications. But the best way to use Angular is to use it with TypeScript. So what are the goodies? What are the nice things we get if we use Angular with TypeScript? We get scalability, because TypeScript is, like we've said, very scalable. Credit to the type system that it brings in. You get cleaner code, because now you have compile time checking. Whenever you are transpiling your code from TypeScript to JavaScript, TypeScript will complain if there are any errors in your code. So this minimizes the chances of you shipping bugs into your production code. It only minimizes it. Bugs will always make their way into production, but using TypeScript, you can minimize those bugs. We also have better tooling. If you use VS Code, for example, it has first-class support for TypeScript, and it has a lot of features that can enhance the productivity of the developer as far as the developer experience is concerned. And also, TypeScript will always have the latest JavaScript features enabled. So for example, if maybe you have a feature that was released in ES6, ES7, ES8, up to ES Next, so you can you can transpile your TypeScript code to the latest version of JavaScript. And you can also transpile your TypeScript code into vanilla JS, or what we call pre-ES 2015. So basically, you have a lot of flexibility on the target version of JavaScript when you are using TypeScript. And yes, you can always rewrite your JavaScript into TypeScript, because as we've said, TypeScript is just JavaScript but with a type system. If you look at Angular specific pros, we have quick project bootstrapping with Angular. Because it's a fully featured framework, we have the way things are done in Angular. So basically, generating an Angular project is very easy, because you only need to tell the Angular CLI, please generate a project for me, and it will generate the project for you with very same defaults that most developers use. So you getting from zero to project is very easy when you're using a fully featured framework such as Angular. And because Angular is written in TypeScript, so it's a win-win, because the development experience is basically seamless, because you're using the primary language that was used to write the framework. So what are the disadvantages? The other side of the coin is Angular is a very humongous framework. If somebody actually tells you that they've mastered Angular, I think they've been using it for not less than 5 years, because it's very extensive. It has a lot of functionality. It has a lot of modules, so it provides a very steep learning curve for you to go from zero to mastery in Angular. It will take you a very long time. And because it's a fully featured framework, at the end of the day, after you've transpiled your code, it's a little bit heavy, because you'll have larger JavaScript bundles that will be generated when you build your application. So because it's heavy, it's also slower if you compare it to other frameworks which are basically lightweight, such as something like Vue.js. Sometimes people want to compare Angular to React, but usually I find that is an unfair comparison, because if you look at React is a very lightweight library, whereas Angular is a full-featured framework. So it's basically an apples to oranges comparison. If you compared Angular and Vue.js, on the other hand, that would be a fair comparison, because it's framework going against a framework. So if you compare Angular with Vue.js, it's slower, not very slow, but it's a little bit slower because it's heavy. And also, migrating large applications from raw JavaScript or from plain JavaScript into TypeScript can be time consuming, because if you started out as a small application and then ended up with a very large application, chances are, if you are rewriting it into TypeScript, it's going to take you a very long time. And testament to this, if you look at the current NPM libraries, for example, most of them have realized that yes, TypeScript is necessary because of the goodies that it brings to the table. But instead of rewriting their entire libraries into TypeScript, what they do is they create a type definition file. So that if you install that library into a TypeScript application, it will tell you, the type definition file will tell you what kind of functionality you are looking at. So usually the type definition file will have a lot of classes and interfaces and namespaces, just explaining to you how that particular library works. So if you look at the types namespace in NPM, it has a lot of libraries in there, because most of the developers have realized that, hey, we need to put our library into TypeScript, but instead of rewriting the entire library, let's just create a type definition to help the developers who are using our library when they install this library into a TypeScript project. So basically, at the end of the day, if you started out writing a vanilla JavaScript application, and it grew to be a quite a big application. If you want to rewrite the entire application into TypeScript, it could be very time consuming. So Angular, TypeScript, and GIS. I know most of us here are interested in GIS or something to do with GIS. So what is the role that Angular and TypeScript have to play as far as GIS is concerned? Like I've said initially, the major GIS libraries for JavaScript, they have type definitions. Basically, it means you can use them in TypeScript projects. So if you look at Mapbox.gl, Google Maps, everything, most of the JavaScript libraries, they will have type definitions so that they make it very seamless to use them in TypeScript. And because you can now use your favorite web mapping library or your favorite JavaScript library with TypeScript, because you now have a type definition file, it means you can get all the goodies, all the scalability, all the robustness that TypeScript brings into JavaScript. So now your applications become more robust and much more scalable. So extension libraries do exist for some of for Angular and other front-end frameworks. So Mapbox.gl, we have React Mapbox.gl for using for bringing in components that that exist in Mapbox.gl and using them in React. We have Angular Google Maps, which is a project to bring in components for Google Maps into an Angular project. So basically, so many of these extensions have been written to support these frameworks and to support TypeScript in the GIS ecosystem. So if you are doing GIS-based front-end applications, you're doing embedded web maps, you'll have a lot of functionality, or you'll have a lot of support as far as TypeScript and these front-end frameworks is concerned. And then if you're going for back-end applications with Node.js, writing such applications with Node.js and PostGIS, you also have support for TypeScript, because most of these libraries have either been ported to TypeScript or incorporate type definition files. Tough.js, which is a very popular library, JavaScript library for doing GIS stuff, has support for TypeScript. So yeah, you can incorporate it in your GIS workflows, which are based on JavaScript and TypeScript. The JavaScript topology suite, which is based on the Java topology suite, is basically a way to bring in the geometry calculations that have been supported by Java and C++ into JavaScript. And yes, we do have TypeScript bindings and type definitions for these libraries. So basically, most of the libraries that you use to build geospatial enabled applications in JavaScript, they have support for TypeScript, they have support for these front-end frameworks, and it makes it very easy to use them in that ecosystem. So I think that brings me to the end of this presentation. I think it's been quite long. So yes, let's have a Q&A session. Let's have a few things to talk about as far as React, as far as Angular and TypeScript in GIS are concerned. So Brian,
Yeah.
over to you.
Oh yeah, thanks. That's an amazing talk and presentation. So my question is, have you tried? Since you have access to your interface, I think you can go to the browser and have you tried Tough.js, utilizing Tough.js, and how was also the process? I've also tried using open layers with Angular, and that was your experience too.
Okay, so I have tried using open layers in Angular, and it was basically a very good experience for me, because basically, if you're using TypeScript, you'll have very good support for that particular project in an Angular ecosystem. So if you're bringing in your JavaScript library, it will have very good support as far as it has type definition files. It will have very good support, and that way you will have no problem integrating it into an Angular application.
Okay.
Yeah.
Does anyone have a question? You can shoot it out. Okay, another question from my end is like which resources do you recommend for someone who wants to start out on Angular?
I can easily say that you can go to the documentation, because the Angular documentation, I believe, is one of the well-written documentations around. But basically, sometimes going straight into the documentation isn't really a good way of introducing yourself to a framework. So basically, I would recommend some tutorials. We have some very good online tutorials on YouTube, or even on Plural site. So if somebody's on Plural site, they can have very good tutorials over there. There's actually one particularly written by a woman named Deborah Kurata. She writes very good Angular code. I mean, she's one of the people that made me learn Angular very fast. So if you are interested, definitely check out Deborah Kurata. Let me just quickly write the name in the chat. If you look up that lady, she has some of the best Angular tutorials going around. We also have another guy. I think Brian should be familiar with this guy, called Steven Grider. He has very interesting tutorials. Basically, very interesting tutorial. He also has a very interesting tutorial on TypeScript. I'm actually going through it right now as we speak. It's a very interesting tutorial on TypeScript, and then he also has an interesting tutorial on Angular. So basically, if you can check out Steven Grider or Deborah Kurata, you can have a very good starting point just to get your feet wet with the framework. I think another person that you can also check out, he has a channel on YouTube. He's called Mosh Hamedani. I think his channel is called Programming with Mosh.
Yeah, or coding with Mosh. Yeah, I think something to do with that.
Either Programming with Mosh or Coding with Mosh. He also has some very good Angular tutorials.
Yeah.
Yeah, so those are just but a few of the resources to get one started on basically doing Angular and TypeScript stuff.
Yeah. So I think in Germany, Angular as a framework and React as a library, they tend to have the same market share. I don't know about Kenya. Have you ever looked into Kenyan market scene?
Talking from experience, I think React is much more popular if you consider the Kenyan market. I believe React is much more popular if you consider the Kenyan market, because React allows you to quickly, it's lightweight. So if you feel that many people that are starting a new application or are just creating an MVP, a minimum viable product, they will tend to go for React just in the short term. So basically, React will have, I believe React has a higher market share in the Kenyan economy if you consider it. But Angular is also gaining traction, because if you look at the enterprise level applications, if you look at SaaS applications, for example, you'll find that most of them will be written in Angular, because Angular provides you with that scalability to be able to write that kind of application, because SaaS applications usually have a lot of considerations to take in place. So they are usually very robust applications, and the best way to architect them is by using Angular and TypeScript.
Perfect. Yeah. I think more we can have some day because I added React on the session. Yeah, we can also have a day for Angular after that, so that maybe just showcase a simple web map service, like yeah, components with a map. Yeah.
Yeah, I think that's in order.
Yeah.
Yeah, I think we can create like a small application, a web mapping application with some of the favorite mapping libraries out there, maybe Leaflet or OpenLayers or
Yes.
Mapbox.
Yeah.
Yeah, any of those can do. Then we can implement it with one of the frameworks, either Angular, or even we can even implement it with both.
Both, yeah, React and
Yeah,
Angular.
we can do one with Angular and then do another one with React, and then look at the differences and the developer experience as far as these two frameworks are concerned. Yeah.
Yeah, perfect. Yeah. Cool. Yeah, I think that's it. It was definitely amazing presentation. I don't know if anybody has got a question you can shoot before we shut down in the next, let me say 3 minutes or 5 to be more lenient if there's anyone who has got a question. Nobody has got a question? Okay. Seems we'll shoot. Yeah, definitely we'll always share the resources, the link. If there's any resources you did grasp or get to know about, but yeah, we'll always share. Yeah, thanks guys for participating, and yeah, it's great. It's you now to really take the initiative and build up yourself. Here's stuff, Jazz. What Moa mentioned, it's about just doing also some JS stuff on the browser. It looks great with the awesome documentation. So yeah, but definitely one usually needs to start with the basics. If it's Java, if you are interested on the front end, definitely you need to start with HTML and CSS, and it's usually not tough. It's actually HTML and CSS are usually kind of easy because it's just about tags and styling. So the head, it's just a simple way of creating a website in a simple way. Like this is the code that you can have a section where you want your map to appear and just simple styling. You don't need to dive deep into it before going into JavaScript. And it's easy to pick up. Okay, that's it. It was great session. Then we can say bye bye. Bye bye to all. Okay, I'm ending the meeting if there's no more talk. I'm ending the meeting in the next 2 minutes.
So we are having another session in 2 weeks.
Yes, it will be about R.
Oh, it will be an R presentation. I'm really looking forward to that. I've seen a lot of R code going around.
Yeah.
I've also had the opportunity to build Docker images for some R projects.
Awesome.
But because I wasn't really into the code, I was just doing the DevOps thing.
Yeah.
I would really want to see how like people do things in R and compare them how I do them with JavaScript or maybe Python. So yeah, I guess that would be one of the presentations we look forward. So yeah, in 2 weeks, can't wait.
Yeah, the app is here. Even Wycliffe is here. Is doing his PhD in Bonn, in Germany. He's using R a lot. Maybe he can give us a talk on his project. Soon, right, Wycliffe?
Yeah, maybe that will be possible. I'm still working on some other things, but
Yeah.
of course, presenting something small won't be a big deal.
Sure. Amazing.
Okay.
Okay, guys, I'm ending it. Bye. It was good. See you after 2 weeks later.